You will see this on any graded event you have next time. You have, let me erase what I have up here. Oh. The ball is thrown. The one you have, the ball is thrown up in the air at 2 meters, so it's not going to start from 0. So a ball is thrown with velocity, like it's like you're on the ground and throwing the ball, like basketball throw. Remember that, to get in here? So your ball is thrown. Yeah, some people do well at it. So picture the ball throw, basketball throw. You're on your knees and you throw that basketball. Up it goes and then down it goes. For some people, it ends up a little bit closer than for other people. So here you have this ball throw. And the first question is, I graph it. If I have the answer, I'm going to get it. So there it is. I just graphed it, and I can tell you the answers right away. The maximum height looks about 100. And it's probably the slope is getting close to 0, right? Because it's about to flatten out. The roller coaster part is about to hit the top. You guys are bored because you're looking at the clock. Don't you hate when a teacher knows body language that much? So here, they ask for the slope, the velocity at 96 feet. 96 feet is around here. So I keep my units all straight. These are feet, these are seconds. And right here is about 96. So it's positive here and negative here. And it looks like it happens around 2 to 3 seconds. So the velocity is the derivative of position. That we're going to make a note card for that. Maybe not today, but we need that. So I take the derivative. It's just power rule. So you get 80 minus 32t. You got to do that right, or the rest of this becomes horrible. So the first thing is s prime is 0 is where it's going to be at its maximum height. I kind of know that because it's a parabola. So I know some things. So I set s prime equal to 0, and it happens at 2.5 seconds. I just did the algebra. Then I stick that 2.5 into s because they ask me for the maximum height, not the seconds. I have to be aware of what I'm plugging into what. And that gives me 100. Dang, I'm pretty good, aren't I? This is why this is useless. This is why it's useless. I can just graph it and see. And if I need precision, then I'll tell mathematically to do the whole thing for me. So that's why this is useless. And I'm recording myself saying calculus is completely useless. Aren't I good? My guess? I got it right, just by my guess. All right, the second question is, what's the velocity of the ball when it's 96 feet above the ground? This is the formula for velocity, but I need to plug in a t value. I don't know when. It's around 2 seconds that we're about 96, just from my eyeball test. You see it? Can you see from that far back, really? Around 2 seconds is when you're 96. So I actually hate doing factoring, but I need the t value. When s is 95, they're asking for exact answers. I'm recording myself saying this. I knew enough to deceive my teachers. So if I didn't know how to do the calculations, I knew enough from looking at this graph how to deceive the teacher and make them feel that I knew what I was doing, because I could see the answers. I wouldn't have done well here. I definitely deceived my math teachers quite a few times. So how do I do that? I have to solve this equation. I did that first, but actually the whole thing's divisible by 16. So you can divide this whole thing by 16, you get this, and you factor. So I think you guys are not going to like that part. So I suggest strongly that you learn to graph things quickly. You're allowed to use Excel. You can graph on Excel. You have a graphing calculator. You can graph on that. I have an extra graphing calculator at home if anybody wants to borrow it. All right, so I get 2 and 3. That makes sense if I look at my picture. 90, no, it's supposed to be 96, right? 96 is around here and 3 is like that. So that's right. And then I plug those numbers into the derivative. So I got s prime 16 when I plugged in 2. And s prime is minus 16, which looks like it makes sense, right? It just looks like positive slope and exactly the same negative slope, doesn't it? Symmetric. So answers look like they make sense. So this is yours. This is the one you were assigned. It's a little bit different. Your curve looks kind of like this. I didn't graph it on Mathematica, but they start at 0. It's actually 2 feet tall or something like that, 2 meters above the ground. And then they throw. So it's like, it's kind of like the power, but they're not throwing it backwards. I guess you could be throwing it backwards. And this is the trajectory you're going to get. For some people, it goes straight up in the air and goes up behind them. For some people, it actually went in front of them. I saw people throwing the medicine ball and it went in front of them instead of behind them. I was like, God, at least I'm not that guy. All right, the velocity, initial velocity is 24.5 meters per second. What does that mean? Louder. The derivative right at 0. So this number right here, see, I don't want to write on this, but this number right here is the derivative at 0. So it's s prime of 0. You might want to jot that down so you know where to use that. And then when does it reach its maximum height? You do the same work I did for the previous problem. Same work. Take the derivative, set it equal to 0. That'll give you its maximum height. When does it hit the ground? How do you have to solve that? Projectile hits the ground. This when this curve hits the ground. That's the original curve. So when the height equals 0. So set the height equal to 0. So that's the factoring business. And don't go on Mathematica and solve it. Although I was quite tempted to do that because you'll probably have to do it by hand in here. So just get some practice at that. And next time, last one is, what velocity does it hit the ground at? What you have to do, I'm recording this, I want everyone to get this right because I'm spending time with you on this. Right? What you have to do is take the derivative, which you already have, and then plug in the value of t when it hits the ground. So you take the answer from d and plug it into the derivative, and that will tell you what velocity it hit the ground with. Does that make sense? You guys in the barracks doing okay?
Yes, ma'am.
You guys should be able to knock out these homework problems pretty quick, and you have to because it's due Thursday. All right, so you have concept quiz tomorrow. Tomorrow's concept quiz I want you to do really well on because I'm thinking about it now. Forrest?
Is there like a reason that the turnover for this specific homework is like so fast?
I have no idea.
Just kind of play out?
Yeah. I'll put the notebooks outside my door so that you can get them quickly.